Enjoy the session, everyone.
Thank you, Liz. Good morning, or whatever time of day it is for you, everyone. It's nice to have you here. I would like to speak about cloud-based analytics today, and I want to talk specifically about what are some of the advantages of going to the cloud for analytics. I am Rachel Martino. I work for Pragmatic Works. I assume you know our company and our combination of products, services, and training, but my contact information is down here in the lower left corner of this slide. And I just want to emphasize that if you have any questions about what we're talking about today, you can reach directly out to me. I will post a blog posting about this on my blog, which is listed here as well, later on tonight, and that should cover will include the slides as well. I am pictured here with my husband in Japan this summer, and I have been in the IT industry for many years. I've worked on SQL Server and Oracle databases. I started out as a database developer, but did a lot of work developing web applications. That brought me closer and closer to the business intelligence world, where I spent a number of years building business intelligence systems and managing the development of that kind of environment within an organization for which that was rather new concept. So I understand a lot of those challenges. I am very much focused on BI and analytics with a great emphasis on helping you build a culture of valuing data and using data for insights within your own organizations. That's fundamentally where my interests lie. BI and analytics are tool sets that contribute to that culture. Somewhat unusually for Pragmatic Works, I am an area resident in Boston, greater Boston area. So if you're in the Northeast, we may get a chance to work together sometime soon. I'm a Ravelry fan, and I'm very interested in knitting and working with fiber for various purposes, but using it to create wonderful things. I think Ravelry is an excellent source of data, and someday I'm going to get my hands on it and do some analysis. But today we're here to talk about the benefits of moving analytics tools to the cloud. I want to start with an overview of what is an analytics project, because I think it's important that we get a grasp on the elements of that kind of project so that we're all talking about the same sorts of activities when we talk about analytics. I also will present you with some examples of using Azure-based cloud tools to execute analytics activities. But let's start with what is analytics. I've got the dictionary definition here. It's the classic definition of analytics, and unlike many terms in our information industry, we haven't twisted the meaning of this term very much at all. We really are doing systematic and computational analysis of data or statistics. And the information that results from that analysis is our primary tool to accomplish our objective, which is providing business value and information that drives business insights. What I really liked about this definition, which I got off of Google, is the increase in mentions, really starting in about, I think, maybe the 60s, which is when computing started to take off, and just an incredible growth in the mentions of this term in the last 10 or 20 years. This Gartner definition of 6 elements of analytics projects is a few years old now, but I like it because it breaks down what we're talking about when we talk about analytics and helps us to provide a framework that enables us to talk about the components and start to classify the tools that we're going to talk about later on as applying to different elements. So I want to spend a minute here and talk about these 6 elements. Data sources are a significant challenge in the world of analytics. I suspect that many of you are well aware of this. The volume of information that we're using is frequently daunting and provides us with implementation challenges. We need to move that data closer to our computing or closer to our applications in order to be able to provide responsive results. We need to be aware of the fact that the data is constantly being updated, but may at the same time have quality issues. So we've got to be very careful about what information gets used in our analytics and in our visualizations of information. So the data sources that we use to accomplish these tasks become increasingly powerful in order to help us mitigate some of these challenges. Data models are the next important element here, and this is key to helping us provide an analytic platform that is structured in a way that it mimics the behavior of the systems that we're looking to simulate. So the objective of capturing this data is to quantify elements of activities that are taking place within our businesses. But those quantifications in and of themselves, how many widget X's were ordered last year, may be too highly aggregated for us to make use of them. Maybe what's most important is for us to get the model put together in a little bit different way so that we know how many people who ordered widget Y ordered widget X and how many orders of widget X were initiated in that way. We're increasingly setting up more and more complicated data models in order to more closely simulate the business processes that we're trying to analyze. So our data models are an extremely important part of the environment. Processing applications are an area where especially when you're working with larger data sets or more complex data sets, we can really get into resource issues because it takes a considerable amount of effort and time to cleanse and modify our data in order to make it into a format that fits into our model. The process of adding in new information on a regular basis, whether you're streaming or executing an ETL as a batch process, it still can be a computationally heavy activity, and you need a processing environment that's capable of executing that activity. Computing power is really the machine measurement of what it takes to execute not just that processing that we're talking about, but also what it takes to run the algorithms that we need in order to do an effective analysis or present a visualization that is useful and meaningful to our users. The truth is that some of our machine learning algorithms can run hundreds of simulations in order to test and find the best solution, and it takes a significant computing power to execute an activity like that. when I say analytics models, I'm talking about something a little bit different than data models. What I'm talking about is the statistical models that are used for building out the analysis of your data and then turning that into valuable business insights. The process of building an analytics model is a very, very different process than what we're used to in the application development world. It is more experiment-based and is highly iterative, but the process has built into it methodologies for coming closer and closer to the best solution possible. And once you have that model built, then that's the tool that you use for predictive analytics. I'm going to show you an example of this later. Being able to use those analytics models and to visualize the results of predictive analytics or even BI is the step of sharing and storing results. The truth is that unless we present the results of all of this analysis and visualization activities, and unless we share it within our organization, then there won't be any business value. So there's been a real growth in the need for powerful visualizations in addition to the ability to analyze that data. So with a foundation in analytics and understanding what some of the major elements are, I want to spend a moment just talking about the data sources and some of the challenges that we find there. As I mentioned, that's one of the areas where we find the heaviest and most consistent need for increasing power. And that's partly because of the 3 V's that we sometimes talk about related to analytics. The volume of data that we use is often significant. We've already talked about that a little bit. But going back to that for a second, moving that data around, affecting change on the content of that data to cleanse it, to ensure the quality of the scope of the data set, that it's covering the right time periods, etc., is crucial activity in our data analysis. And our data storage environment is expected to aid in that process. Velocity of data is of increasing concern these days. We have more and more businesses starting to uptake analytics on information coming in from various devices that is approaching real time, which is a significant challenge and one very different from the challenges we've faced in the past, where we've frequently operated on a batch model related to our data sets. And the variety of data is increasingly complicating our environments. We're getting information from multiple places and multiple forms, and it needs to be combined in a way that it can provide us with a holistic result. Excuse me. The truth is that we didn't stop with 5 V's. This V metaphor has continued on and provided us with veracity as our 4th V, which is crucially important. The fact is that if people doubt the truthfulness or the accuracy of the information in your solution, then they will doubt the capability of your solution to ever provide accurate information. So veracity is fundamental, despite the fact that it wasn't one of the original 3 V's. And we need to ensure that we are providing current information, that all of the information we're providing is consistent with each other, and that we are respecting the business rules and the type of information that is expected from our input systems. So just as an aside, Pragmatic Works has a tool called Legitest that is designed to help with this, because we do see that this is one of the most significant challenges facing many BI and analytics programs today. The value of our data is something that is becoming increasingly apparent in our businesses. We are starting to truly view data as an asset of the organization. It is becoming apparent that we can leverage data to solve problems and provide us with insights into the way our business processes are completed, and that can be done increasingly in a way that embeds that process into our activities or the activities of our business decision makers. And this means that the inherent value of the data must be respected, and it must be managed as a valuable asset of the firm. There's only two more V's, I promise. Variability and visualization. Variability is really related to the fact that your information that you're gathering will change over time. So the problem of analysis is not something that is a one and done. You begin your analysis and you provide your predictive models many times in analytics, or you provide your data model, or you provide your visualization, but you need to revisit and be sure that you understand that over time things may change. Data available to you may change. The information you're currently capturing might be different, but inherently we know that the orders that are being placed for widgets Y and X might be different in the fall of 2016 than they were in the fall of 2014. And certainly, if we're talking about a retail kind of order, that may even change season to season, not just year to year. So we need to be aware of the variability of our data as well. I've already spoken about visualization, but I don't think I'm overstating it to point out that visualization is the most powerful way that users can interpret our data in most cases. An argument might be made for notifications, but I really believe that despite the need for an alert, the fact is that viewing information in a visual format provides us with much more rich and a better overview of our data than we can get by looking at a table or a particular data point. So the ability of the human brain to absorb information out of a well-delivered visual is something that we need to respect in our process, and the number of visualization tools on the market to support that process it confirms the need for this and the need for improvement in this arena. So the 7 V's really help us cover data sources, but why do we want to go to the cloud for these activities? We've talked about analytics and what it comprises, and we've talked about the challenges that we face in some particular areas there, but what is it that the cloud brings that we are not able to accomplish on premises in our own data center? And the truth is that in the cloud there are some capabilities of scale and economy and security that go beyond what we can accomplish on-prem. To think about scalability, I think the two words that come to mind most quickly for me are agility and flexibility. The cloud provides us with the ability to power up a large data source, data store, use it, and then power it down when it's not in use. That's a very difficult thing to do on premises. If we need heavy computing capability in the cloud, then we pay for it by the unit. We pay for what we use, and when we're not using it, we're not paying for it. And so ensuring that this is the case is crucial, but the flexibility of those tools does enable that and empowers us to have that kind of control over our environment. If you were to stand up that kind of capability as a new environment within your own data center, you would need to, even just to execute a pilot, you would need to stand up hardware, implement the software, and you would have to stand up enough resources to handle the heaviest load at all times. One of the other scalability features that I think is incredibly powerful for the cloud is the ability to integrate data sources together and to provide visualizations across multiple data source environments and using analytics. And this, I think, is more difficult to replicate internally and requires many internal tools are not as advanced as some of those we're using in the cloud these days. Excuse me for drinking. I've got a bit of a tickle. Sorry. But really, the reason to go to the cloud fundamentally is the capability that the cloud brings to us. The cloud tools that are provided by Azure integrate with desktop tools by being able to embed solutions, visualizations. We can use Excel to view predictive results from Azure Machine Learning. We can combine models that we create on the desktop and share them into the cloud. And really overall the integration capability between the desktop and the cloud is growing and is a very, very powerful combination, especially the ability to embed tools from Power BI into applications now. The capabilities in the cloud also benefit from interfaces that are more similar to consumer technology interfaces than they are to high-powered, highly featured software. And that is important because it enables a lower bar to entry on cloud services and provides your team and your skill set with a real jump start in moving to those environments. The collaboration capability provided by the cloud is also quite impressive. There are not just the ability to access cloud sources from anywhere on the internet, but also combined and integrated systems that enable collaboration at the project level so that people can share information, comment on information, share documentation about their cloud solutions. And I'm specifically thinking here of like a Power BI workspaces environment where it comes along with exchange groups and some inherent security, as well as OneDrive capability and SharePoint groups. It's all tied together in a way that empowers the users to work together to improve the tools that they have. And then fundamentally, it's the powerful server capabilities, just the sheer power that is brought to bear in Azure and in Power BI world, which is part of Azure, to provide fast and very beautiful implementations of solutions. An overview of the tools provided by cloud-based analytics, for cloud-based analytics by Microsoft, is really an overview of the Cortana Intelligence Suite. The major elements of that suite as defined by Microsoft are listed here. They don't exactly align to what we had for Gartner, but everything's included here. We're going to sort of overlay that a little bit later. But the view that I've shown you here gives you an idea of the depth of offerings available in each of these major elements. The capabilities really go beyond what we see here and even down into SQL Server 2016 capabilities as well. So the Cortana Intelligence Suite, these capabilities you see here are cloud-based, but we shouldn't underestimate the hybrid cloud capabilities that are inherent with the tools offered by this platform as well. Today we're going to get a chance to take a look at SQL DW and blob storage in the big data store segment here, machine learning and advanced analytics, and also some Power BI. So there's a lot offered by this environment, and we don't have time to talk about everything, but it is important to note that the Cortana Intelligence Suite goes well beyond the topics we're going to be able to dig in on today. But one more thing before we get to demonstration, and that is a discussion of how do businesses benefit from going to the cloud. The diagram on the left shows the cycle that is empowered when your business is implementing a data culture and, well, really operating as a data culture, frankly, and is using data to leverage the employee's ability to solve problems and predict trends based on data, and using those facts provide insights to the business, and all of this builds value to the organization. I want to talk about some specific examples we've seen in the last few months of companies that have looked to the cloud for improvements or expansions on their ability to implement analysis. The first example I have listed here is a testing company that was looking to begin a process of using data pulled from test takers and test centers in order to determine fraud probability, and to understand what the correlations are between various behaviors or characteristics of those situations, test-taking situations, and which would be indicators of fraud. And the objective here was really to take a huge amount of information gathered by the firm and learn from it a model for understanding fraud and how to find it, and then to build a predictive tool that will enable fraud detection going forward. The capabilities inherent in Azure expand on that, or in the cloud, frankly, expand on the ability of the company to execute this sort of analysis and provide a tool set that makes this a much more straightforward analysis than what it had been previously for them. We've also worked with a insurance company we've worked with a couple of insurance companies, frankly, who are executing massive calculations for loss prediction internally and are finding that they are unable to deliver the value that they need internally for various reasons and are looking to the cloud to bring more computing resources to bear to this problem in order to get to faster answers or to improve the usability of the solution set because of limitations of the current on-premises solutions. Another example, and a very powerful one, is a company that's opening up a completely new set of service capabilities by augmenting their health device that is a personal device tied to a person's cell phone and adding to that device the power of cloud-based analysis in order to improve performance. So taking what previously was a communication between the device and maybe a cell phone and augmenting that communication with the power of analysis in the cloud to provide better service to the customer and frankly just pure more compute power for those services and a broader data source access and further integration with other data to improve the service capabilities on the personal devices. While I'm talking about this slide and how does my business benefit, which I think is fundamentally the most crucial question we're going to talk about today, I want to point out that at the end of this slide deck is a slide of resources, and in that list of resources I have also referenced a few other good articles from the internet that talk about how various tools that we're talking about today benefit businesses right now through providing increased business value. So these are three examples that I thought were particularly apropos, but there are more in the references section. Okay, so what I'd like to do next is show you some of these tools in action. The first thing I would like to show you is the I'm sorry, I'm trying to click and speak at the same time. It's not really working out that well. I want to show you some data store because we started talking about data store, and it's important that you see how the data store can contribute to a powerful analytics experience. I do believe that you can now see an image of an Azure VM actually that is showing a window of the Microsoft Azure Storage Explorer. And in Azure Storage Explorer there are 12 files loaded here that are all named trip data with an integer that follows, and each of them is over 2 gig in size. These are text files of New York taxi cab trips in the year 2013, and each of the files is 1 month worth of trips. The data has been loaded into Azure Blob Storage, and it was as easy as uploading the files in this interface. So I just pulled the files into this location, or you can upload an entire folder at a time. And from this location, I was able to come into Azure SQL Data Warehouse and access the Azure storage directly. I've gone through these steps already, so I won't put you through all of the steps that it takes, but in Azure SQL DW, which is this server that I'm showing here over in the Object Explorer, there is a database that's called Pragmatic Works Principal Consultants, New York City Taxi Data Warehouse. It's a very long name. And in that data warehouse are a number of tables that are, there's some that are referenced under a folder called external tables. These tables are all tables that are actually external data that is hosted in Azure Blob Storage. To link each of these external tables, I went through this process that we see here in the query window. I created a master key and then scoped the credentials for my Azure storage, and we called it the Azure Storage Credential, and it points to the blob storage, and I put in my secret code here, which I'm going to hope you weren't able to just copy off the screen. And then I pointed to an external data source, which I called Azure Storage. It's of type Hadoop, and its location is in the New York City taxi folder of the PWPCE storage blob store, and that is this location here. And we can see over in Azure Storage Explorer that I'm in the New York taxi folder of a storage location called PWPCE storage. Once that was executed, then I defined a file format that was a text file as the format of the file, and I executed this statement, which was create external table. Now, creating that external table is really a very quick activity, and in fact, I'll go ahead and just delete this. So now it's gone. And I'll go ahead and rerun that statement. Oh, I'm on the wrong database, sorry. Apologize, I'm in the wrong server. There we go. Now we're in the right database, and now we can run this statement. And what it's doing now is it's going to my Azure Storage data source that I had defined, and it's looking in that location specified by the Azure Storage database, and we'll just scroll back up and look at that, and the location includes the folder name, and it's grabbing all of the files and reading them with the format of text file. And now that I've done that, I can literally query that external table and query all of those blob stored text files to get a count of my trip data. Now it takes a few moments to get this count of the trip data. So this response is going to work, I promise you, and you will see it work. But I found it to be slower than I thought was reasonable for my user experience. We're talking about the need for a valid and responsive user visualization experience here. And for me, although this is a very powerful tool to be able to connect straight to blob storage, it just wasn't fast enough. And frankly, I'm not sure I'll get a chance to demonstrate Data Lake, but I found that although Data Lake was more responsive, it also was not sufficient. So the next thing I did was I created a table. In the original case, it was called New York City Taxi Trips, but I'm showing you here the way I did it. I created that table with a clustered column store index, and I use the select statement to pull the content from those text files, and in many cases to cast it as the modeled data element data type that I needed in my data model so that it accurately reflected the model process that I was trying to simulate. So you can see here that in the process of defining the data that's going into my data warehouse, I have been modeling that data model. So we've got this combination here of storage and data modeling going on. And when that create table activity completed, I had this table here. And now you're seeing how long it's taking to select from the block storage, but I can select the first 1,000 rows of that New York taxi trip table much, much faster. This is taking SQL data warehouse and column store data modeling and allowing me, data storage I should say, and allowing me with very, very quick access to the index data that's in this storage location. The data warehouse structure is close enough to my model for my purposes that I am actually able to use it. So let me just switch to the right version of my browser. That I can access that solution from Power BI reports and use that data to analyze trips. Now, I pointed out to you that each of those files was 2+ gig. What I didn't mention was that each of those files, which represented 1 month of the year, so there were 12 of them, was actually over 14 million taxi trips for a total of over 173 million rows that we're looking at right now. So what I am showing you is the breakdown of the number of trips in blue and the number of passengers in black per hour for the month of January. And this is actually broken out by time of day, so every hour is represented here, and we can switch to another month and we'll see that there is a bit of a delay, but we're dealing with a huge set of data. And the fact is that the combination of Power BI and Azure Data Warehouse is providing us with a very powerful visualization of this data. I want to show you one more, which is pickups per taxi medallion per holiday. So we've got this list of various holidays, and we can see where were trips picked up on this holiday, and the relative size of the dot shows how many passengers. So we could see that this particular medallion picked up 3 passengers on Independence Day, I think we're looking at here. So powerful capability to visualize a vast amount of information. And to see the entire data set, we can look here. Let's go all the way to the top. And we can see that it takes a little time, but it is able to pull back all of the months of the year and how many trips were executed in that month. So this is a combination of visualization and storage that is very, very powerful and allows us to deal with large quantities of data. But another set of tools that we are really interested in when we talk about analytics is the ability to build analytic machine learning experiments. Excuse me again. I apologize. The Azure Machine Learning Studio is an environment that enables the build out of an analytic model that includes all of the elements we've been talking about. It includes data sources and the cleansing or processing of that data. In this case, the only activity we're really executing is splitting it. The training of a model to provide insights into the data. In this case, we're using a two-class boosted decision tree to train that model. And then the data has been split so that 70%, that's in this detail section over here, 70% of that data is being used to train the model, but after the model is trained, then it is scored against the other 30% of the data, which is why this comes in here. This experiment then is evaluated to see what the quality of the outcome was. So if we think about it, we have passed in, and I'm going to visualize it now, this data set. When I visualize the data set in Azure, I see only a portion of it, but we've actually passed in 32,500 rows of 15 columns each. And we can take a quick look into the details of each of the columns and see that, for instance, the mean age is 38 and a half and the median is 37 with a minimum of 17 and 90. The tool here is providing us with that data insight that we need in order to build a valid analysis. We're looking in at the column level and seeing what is comprising that column of information so that we can make sure that the information that's in there meets our, what is it now, 7 V's of good information, and that we can subsequently, if there's an issue, we can clean out any bad data, we can fix data issues should they arise. The information that I'm accessing here is actually income information from a census of adults, and the data is coming to us from a data set loaded in Azure Machine Learning Studio. So you can load data sets directly in here. Oops, I'm sorry. And this is just an example of some of the data sets that have been loaded here locally. You're not limited to what data can be loaded in Azure. You can load many gigs of data, and sometimes it's more efficient to use your Azure analytics against a set of data that is stored in one of the other data storage environments. Data storage is very important to our analytic process. We've been talking about that a lot today. And so I want to point out that there are a number of data storage options available to you in Azure Analytics Studio, ML Studio. In this case, we are using a 32,000 row CSV file that's been loaded up. And as I mentioned before, the data is split. 70% of it is used to train a model with a two-class boosted decision tree. But if you look over here, you can see that these trees are being built with, I don't know if you can see the detail here, with a maximum number of 20 leaves per tree, a minimum number of samples of 10, and 100 trees constructed. So this is a significant compute process that's being executed on these 70% of our 32,000 rows. And the outcome then is compared to the information that is in our incoming data. So what I want to point out on the way we train our model is that one of the columns in our input set includes the income of the person whose data has been included in the row. So when we go back and look at our income data source, we have parameters of information about these adults. whether they're married, what their occupations are, what kind of relationships are they holding, what's their level of education, which interestingly has been converted to an education number, you'll notice. That's for ease of quantification of that. And the last column is whether they make more or less than $50,000 a year. This is what we're trying to predict. So it's very important that you know going into the build of an experiment what it is you're trying to predict. And in this case, there are really only two values per entry. Do they make less than or more than $50,000? So our model is trained to execute the statistical process of a two-class boosted decision tree. It gets 70% of the rows. And when that's done, it scores those decision trees by comparing that income value that was predicted by the model against the other 30% of the rows. In other words, it executes those other 30 and checks the 30 that weren't used to train the model and checks the income value on those to see if it's the same. The output is then evaluated and determines how many times it was correct, if there was a true positive or a true negative, and how many times was it wrong. How many times was the person really making more than $50,000 and it said it made less? And the same for the other way around, the false positive. It said they made more and they made less. I think I said the same thing twice, but you get the idea. Once this is run and the model has been trained to a point where the person developing the model believes that it is valid in the majority of cases in delivering the correct or most correct version of the responses, then it can be converted into an experiment. And when it is, then the input to the scoring of the model becomes a new data set provided by a web service. And this is a very exciting opportunity for us because this enables us to run the model remotely. So we can go to our income prediction experiment and we can execute a sample data set against this experiment. So the first thing we need is to grab the URL. And I know we're getting close to time. I apologize for that. I'm going to finish this up very quickly. We need to create a new Excel example and add in Azure Machine Learning. And we can add a web service in Azure Machine Learning. It's important that we provide the API key. This request API is not available to everyone. You have to have the key in order to use it. And when we add this in, we actually have accessed the web service now. And one feature that's provided is some sample data. So I'm just going to click that to get the sample data. And I'm going to doctor the results a little bit. And I happen to know that if you have a capital gain of more than $10,000, that is highly predictive. So this is just sample data that is input to our web service when I select it as our input. And I want to tell it to provide us with output from our web service at this location here. And when I hit predict, now I get not just the prediction, which is that these people all are predicted to make less than 50,000, but these people are predicted to make more than 50,000. And as I mentioned, capital gains is highly predictive of that. And in fact, if we look at the probability that this prediction is correct, we can see that because they had a $10,000 capital gain, it's highly predictive that they be correct. I want to point out that this integration provides the ability to reuse your model that you trained in many, many applications because it's web service based. I'm going to quickly scan over our conclusions because we're rapidly running out of time and point out that many companies start out going to the cloud with Power BI, mostly for the collaboration, the mobile capability, and the ability to visualize and use dashboards. There are significant benefits of using storage provided in Azure, and that predictive analytics with Azure ML are another cloud-based analytic tool that are uniquely designed to provide benefits that are not available on premises. I promised you a reference slide, and this includes many points of information that I think I wasn't able to spend the time on in today's presentation, but that are very useful, especially looking for use cases for stream analytics and for predictive analytics and for information about security as well. I didn't leave much time for questions. I apologize for that, so I'm going to put my slide up with my contact information, but I will stay on as long as you need me to answer any questions you might have. Liz, were there any questions?
Yeah, there are a couple. I know some people are already asking about having your presentation with in particular the references page, and I know that's a yes. Rachel always provides it, and we will definitely put that up on our blog, and she will put it up on her blog as well.
Yes.
All right. Someone wants to know if you can try Azure before you buy it.
Yes, yes. You can go to the Azure Studio link and sign up for free Azure, and you can absolutely try it before you buy it.
And someone also wanted to know that they thought that data modeling on a poly-based query would hinder performance. Is that true?
Well, that's an interesting question. I actually, I suspect that that probably is true, but I wasn't aware of that. I'm going to look into that. Thank you. And I'll include that in my blog post.
Well, those were all the questions we had for now. If you guys think of anything, please feel free to email Rachel. Her contact information is on the screen. You can also email me, Liz, and I'll be happy to pass along any questions to Rachel. Again, thank you everybody for joining us. As always, the recording will be emailed out to you tomorrow. And thank you, Rachel, for hosting today.
Thank you, Liz, and thank you everybody for listening.
Thank you.
Bye-bye now.
Bye.